My name is Nelson Sommerfeldt, and I do research for solar energy in buildings. People really like solar power. They say, oh, what do you do for work? I do solar energy research. Oh, that's great. We need more of that. I've never heard anyone say, I hate that stuff. We don't need any solar energy. That's dumb. So we're on the roof with all the solar panels. And here we have PV, and these make electricity. Behind me on the wall there are solar thermal panels, and they make heat. With our system, we looked at the combination of those two, where the front side makes electricity, and on the back side, we collect all the heat. There's generally two types of solar collectors, those that make heat and those that make electricity. The ones that make electricity are very popular, but they're also kind of inefficient. Of all the solar energy that hits the front of that panel, only 15% becomes electricity. The rest just gets turned into heat and goes into the air. But what we can do is add a collector to the backside and collect some of that heat that's lost. And when we do that, we can take our efficiency from 15% and make it 50 or even 60%. So we've been looking at the combination of hybrid solar panels that make electricity and heat and combining them with ground source heat pumps. And what we do with this is we take a normal PV panel and add this extra piece to it. That allows us to take the heat from the sun and store it in the ground from summer to winter, because we have so much of it during the summertime, right? People think we don't have sunshine here in Sweden. That's not the case. It all just shows up in July when we're on holiday, right? But when you're on holiday, you're swimming, you're not thinking about, oh, I need to be warm in December. And ultimately, we can install more heat pumps in more buildings that we couldn't before. If all you're doing is taking heat out of the ground and the holes are too close together, the ground can freeze. And then you can damage the system if it gets too cold. But what we can do is if we add the solar collectors, then when the heat comes out of the ground, it gets boosted by the collectors, goes into the heat pump. When the heat pump's not running and there's extra heat, we can then put it into the ground. And when we do that, we reheat the ground, right? So we extract heat in the wintertime, and then we can inject heat or add heat in the summertime. So when you have a large building and it needs many holes, you need lots of land, which is something that most housing cooperatives or just larger houses don't have. So there can be a lot of benefit to making those holes closer together or having less of them. On the left, we have 12 boreholes, and this could be enough to provide heat for a normal block of flats, like 30 apartments, let's say. And normally you have about 20 meters spacing between the holes. And when we have 12 holes that are spaced 20 meters apart like this can take up a lot of land. But when we add the solar collectors, if we have enough of them, then we can potentially take away some of the holes here and also reduce the space between them. So you can see here we're down to 10 meters. So in this scenario, we actually reduce the land by over 80%, and it makes it much more possible for apartment buildings to then install ground source heat pumps. So what we've done so far is shown that this concept works, right? So the systems analysis in the computer has shown that there's some potential here. So we have some more detailed work to do on the specific design of the plumbing. We should build more test sites to see how it works in the real world and compare those. And we should also work on making the collectors cheaper, because even though in the long term it makes economic sense, those high investment costs can be a barrier to adoption. So those are the three sort of key areas. Well, people definitely like the idea of having more solar energy. They like the idea of having lower CO2 emissions. And this system idea, this concept, can do both. And to sound really cheesy, the future for solar is really bright. Is that terrible? Like, you can say it like, well, the future for solar is really bright. Yeah. Oh, is it? Yes.